Hello everyone, welcome back to my channel SJR Comtech. In today's session we are going to see BCD, that is binary coded decimal. So today we will see all these points. First one is what is BCD. Second one is if the decimal number is given, then how to convert it to the BCD. Then how to convert BCD to the decimal. Then valid and invalid BCDs. Then packed BCD. And the last one is comparison or difference between the BCD and binary. So what is BCD? This is the short form of the binary coded decimal. So this number system is used to represent the decimal digit using 4 bits. So obviously here we are going to represent the decimal digit using the 4 bits, and as this binary coded decimal is positional or weighted number system, there are 4 weights which are used to represent the number, and those weights are 8, 4, 2, 1. So BCD uses these 4 weighted values 8, 4, 2, 1 to represent the decimal digit using the 4 bits, and that's why this binary coded decimal is also called as the positional or weighted number system. Now decimal digit. So we know how many decimal digits are there in decimal number system. Total 10 digits are there, 0 to 9. So I have written here 0 to 9. After this again I have written 10 to 15. Why I have written, I will tell you. Here we are going to represent the decimal digit using 4 bits. So using 4 bits, how many numbers we can represent? Use the formula 2 raised to n, where n is nothing but the number of bits. So how many bits are used to represent number? 4 bits. So put the value of n as 4. So 2 raised to 4 is equal to 16. So total 16 numbers we can represent by using the 4 bits. So those numbers are 0 to 15. But this system is used to represent only the decimal digits. So 0 to 9, these are called as the decimal digits. Now what about 10 to 15? Here you can see 10 to 15, these are not the decimal digits. These are the combination of the decimal digits which are used to represent the number. So simply we can say 0 to 9, these are the decimal digits, and here 10 to 15, these are the decimal numbers. Okay, now first I will write the 4-bit number for each decimal digit and for these decimal numbers also, and after that I will tell you what are the valid and invalid BCDs. So first 0, how to represent? We have to see all these weighted values. See here, any value, none of the value is 0. So write everywhere 0, 4 times 0. Now to get the 4-bit value for all the remaining numbers, what we have to do? We have to select the weighted values and we have to add those weighted values. After that we should get the result as these numbers. For example, first decimal digit is 1. So is there any weighted value 1? Yes, it is there. So for that weighted value only write 1, and for remaining weighted values we will write 0. So this is the 4-bit equivalent for the 1 using the weight 8, 4, 2, 1. Now next one is 2. Is there any weighted value 2? Yes, it is there. So for that write 1, and for remaining weighted value write 0. Next one is what? 3. So is there any weighted value 3? No, it is not there. So what we have to do in such a case? We have to find out the weighted values in such a way that when we add those weighted values, the result must be 3. So now here I will choose 2 and 1. So 2 and 1. So 2 plus 1 is 3. So write 1, 1, and for remaining 0. Now next one is 4. Yes, directly weighted value 4 is there. So for that write 1. Remaining will be 0. Next 5. 5 is not there, but 4 plus 1 is 5. So 4 is selected, 1 is selected. Here write 0. 6. 4 plus 2, 6. 4 is selected, 2 is selected. For remaining write 0. 7. What we have to select? 4 plus 2, 6. 6 plus 1, 7. So 4, 2, and 1 is selected, write 0 for the 8. Now next one is 8. 8 is there, write 1. Then for remaining write 0. Next 9. 8 plus 1, 9. So 8, 1, then 1, 1. So 8 is selected, 1 is selected, write 0 for remaining weighted values. In same way we can write for the remaining numbers also. So 10, 8 plus 2 is 10. So 8 is selected, 2 is also selected. Next one is 11. 8 plus 2 plus 1. So 10 plus 11. So 1, 0, 1, 1. 12. What we have to select? 8 and 4. So write 1, 1, then 0, 0. 13, 8 plus 4, 12 plus 1, 13. And here write 0. 14. 8 plus 4, 12. 12 plus 2, 14. So triple 1, single 0. And for the 15, 8 plus 4, 12. 12 plus 2, 14. 14 plus 1, 15. So all the weighted value we have to select. So write 4 times 1. So actually this is how we can write the numbers 0 to 15 by using the 8, 4, 2, 1 weighted values. But see, BCD code is used to represent the decimal digit using the 4 bits. So here the decimal digits are from 0 to 9 only. So 0 to 9 BCD representation is called as the valid BCD, and then 10 to 15 these are called as the invalid BCDs. Okay, so how many valid BCDs are there? Total 10, 0 to 9, because these are the decimal digits and these are used to represent the 8, 4, 2, 1. After that, why 10 to 15 these are the invalid BCDs? Because these are the decimal numbers where actually if we want to convert it to the valid, then we have to represent each digit by using the 4 bits. But here you can see, here we have not represented each digit by using the 4 bits. So now how to represent, suppose 12 using the BCD. So suppose here I have written the 12 decimal number. Now I want to write its equivalent BCD. So how to write? 1 and 2. How many digits are there? 2 digits are there. So represent each digit using 4 bits. So the first bit is 1. How to represent 1 using BCD? 000 1. So write 000 1. Now what is next digit? 2. How to write 2 using BCD? 0010. 0010. So actually this is the BCD for the 12. What we have written here? 1100. This is not valid. This is invalid. What is valid? This one is valid. Or this is the correct BCD for the 12. So BCD represents the each decimal digit using the 4 bits. Here I will take one more example. Suppose 156 decimal number is given. How to write its equivalent BCD? Okay. The first one is 1. How to represent 1? Using the 4 bit or using the BCD? 0001. So write here 0001. Next, what is next digit? 5. So how to represent 5 using the BCD? 0101. 0101. Next digit is 6. How to represent using the 4 bits or using the BCD? Or the BCD equivalent of 6. 0110. Okay. So this is the BCD for the given decimal number. So if you know the BCD for the digits 0 to 9, then you can write the BCD equivalent for any given decimal number. So first you have to find out how many digits are there in given number. Then write the BCD equivalent for each digit given in decimal number. So the total bits in BCD is equal to 4 multiplied with the number of digits in decimal number. So 4 multiply with number of digits. How many number of digits are there? 3. So 4 into 3 equal to 12. How many bits are there in BCD? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Now in first example, how many digits are there? 2 digits are there. So 4 multiply with 2. Why to multiply with 4? Because 2 represent each digit we are using the 4 bits. So 4 into 2, 8. So here also you can see how many bits are there in BCD? 8 bits are there, as 2 digits are given in the decimal number. So this is how we can convert the decimal to the BCD. So we have finished decimal to the BCD as well as what is BCD and valid and invalid BCD. Now the next one is what is packed BCD. Now here you can see 156, 12 is there. Decimal digits are only from 0 to 9. After this, whatever number we are going to represent, that is nothing but the combination of the digits 0 to 9. So, when we use the BCD to represent any decimal number from 9 onward is called as the packed BCD. So, after 9 we can represent 10, 11, 12, 13, 14, 15, 16, 17, 156, 1000. Whatever number from 9 onward, those are called as the packed BCDs. So here the example of the packed BCD is 156, then 12. So these are the packed BCDs. Now the next one is how to convert the given BCD to the decimal. Suppose the given BCD number is suppose 1001, then here 0101, then 1100. Okay. So this is the given BCD. Now I want to convert this into its equivalent decimal. How to convert? First important thing we have to remember, when we have converted the decimal to the BCD, we have replaced each decimal digit using the 4 bits. So, when we are converting BCD back to the decimal, that time we have to form a group of 4 bits from the right side. Okay. So, how many groups are there? 3 groups are there in the given example. After that, we have to replace each group by its equivalent decimal. So first one is 0011, its equivalent decimal is 3. Then 1010, this is actually 1010, 8 plus 2, it will become 10. That is invalid BCD. So this is not valid BCD. I will change this example to 1000. So 1000 is 8. Next one is 1001, it is 9. So the equivalent decimal number is 389. As this is decimal number, the base is 10. Now I will take one more example here. Suppose the given BCD is Suppose this is the given BCD. Now we want to convert this BCD into its equivalent decimal. Again the same process we have to follow. We have to form a group of the 4 bits from the right side towards the left side. So the first group from the right side is 0110. Now the next group, next, and see the last group. Now you can see these groups are containing 4 bits. What about last group? It contains only 3 bits. But we have to form a group of the 4 bits. So add single 0 to the left of this number, because when we add 0, it will not change the value of the number. Now this group is containing 3 bits. So I have added single 0. Suppose in another example, the last group is containing only 2 bits. So in that case, you will add 2 zeros. If this group is containing a single bit, then we have to add 3 zeros. Okay, so here we have to add the required number of zeros, and we have to see how many bits are there in the last group. Now replace each group by its equivalent decimal. 0 1 0 1. Where is 0 1 0 1? 0 1 0 1. What is its equivalent decimal? That is 5. Next 1 0 0 1. This is 9. Then 0 1 0 1. Again it is also 5. Last one is 0 1 1 0. It is 6. So the equivalent decimal is 5 9 5 6. And as this is decimal, the base is going to be 10. Okay, so we have finished with the BCD to the decimal conversion also. Now the only last point is remaining, that is comparison of BCD and binary. Here you can see the simple example how to represent the 12 using the BCD. When we represented any decimal using the BCD, we have replaced each digit by using its equivalent 4-bit number using the 8421 code. So as 2 digits are there in number, 8 bits are there. Okay. But when we represent the 12 using the binary, that time how many bits it is containing? Only 4 bits. So when we try to represent 15 also using the 4-bit or using the binary, it contains only 4 bits. But if I try to use the BCD to represent the 15, then I will need how many bits? 8 bits, because 4 bits for 1, 4 bits for 5. 4 plus 4, 8. So always the BCD contains too many bits or very lot of bits as compared to the binary number system. So the addition as well as the subtraction becomes very difficult in BCD as compared to the binary. So in short, we can say BCD is not efficient to use as compared to the binary number system. So this is about the binary coded decimal, that is BCD, which is also called as the 8421 code, because it uses the 8421 weighted values to represent each digit using the 4-bit. And there are total 10 valid BCDs 0 to 9, and then 10 to 15 these are the invalid BCDs. And the packed BCD is nothing but the, when we use the BCD to represent the values from from 10 onward, not from 9 onward, 10 onward. So 10, 11, 12, 13, those are called as the packed BCDs. So this is about the BCD. So if you understand, please like video, share it with your friends, and don't forget to click on the subscribe as well as bell icon to get the notification of my next uploaded videos. Thank you.